See you later, bye. We established in the last example that we could find the slope of a curve by doing this little thing where we say f of a plus h minus f of a all over h, and then taking the limit of that as h approaches 0. Now that's just the slope. Slope of what? The tangent line. Okay, so it's the slope of the curve at that point, but that's the slope we use for the tangent line. They're interchangeable. So let's apply this to f of x is equal to 1 over x. Now this is where it gets a little more challenging. Your algebra skills have to be on point. You have to be really good with algebra to do this one. So now here's what this looks like. If I were to ask you to calculate the average rate of change of the function f of x, and we're using a instead of x. So what we would do is we would say the limit of this function as h approaches 0, and we would say f of a plus h minus f of a, whoops, all over h. So now what that would be is that would be 1 over a plus h. Now I'm going to write it like this so you guys could see, but originally think of it like this. If f of x is 1 over x, then it would follow that f of a plus h would be 1 over whatever you have in parentheses, right?
Yeah.
So this would be a plus h. And then naturally f of a would just be 1 over a all over h. And we're going to take the limit of that as h approaches 0. So I'll leave that up so you guys can let it soak in for a second.
Are we marinating?
Yeah. So now what should happen is we should reach a point where everything will cancel that doesn't have an h term in it. We're not there yet. So how do I get there? Well, I'm going to combine these two, and the way that I do this, I have to have a common denominator. So I'm going to multiply this by a, and then I'm going to multiply this by a plus h, right? That gives me a common denominator. You guys remember that trick from back in the day?
Throwback.
So what you would have to do is, to find the common denominator, you could always kind of multiply one denominator by the other, and that'll give you a common denominator. And so when I do that, what I end up with is the limit of the function as h approaches 0 of a minus, so I got a over, and I'm just going to leave this as a times the quantity a plus h, and we'll put that minus sign here, and then I have a plus h all over a times the quantity a plus h. And I'm not quite sure while I'm writing on an angle. That's a little bizarre, but okay.
Oh my gosh.
So now what I want to do is the next thing, and this is all over h, right? So to simplify this, I'm going to say the limit of this stuff, I could say a minus the quantity a plus h all over a times a plus h all over h, right? Could I do it that way? The answer is yes. I might not understand how you did that, Mr. Adams. But I'm basically subtracting this. And since they are the common denominator, I could do that. Right? It would be like saying, what's 3/4 minus 2/4? Well, then I could say 3 minus 2 all over 4, right? I could do that. Okay. But now what I want to do is I want to distribute the -1 through the parentheses. So when I do that, I'm going to get the limit of this function as h approaches 0, but my function would be a minus a plus h all over a times the quantity a plus h all over h. Right? You guys with me so far?
Wait, but if you, like, can you pull that one back up?
Hmm?
Can you put the other picture back up?
Yeah, this one?
The bottom of it. If you subtracted the a plus h on the top right side from the a plus h on the bottom left side, why would it still be there?
What makes you think we could subtract this?
Oh, I thought that's what you said. Wait, what did you subtract? You said you subtracted something.
I'm subtracting this.
Oh, never mind.
Okay. Are we good?
Yes.
Okay. So now, an interesting thing takes place. This A cancels with this A, right?
Yes.
Wouldn't that be a negative h? Yeah.
Ah, yes, you're correct. That would be a negative h. I'm sorry. When we push that through, that's a negative h. So what I really have is the limit as h approaches 0 of negative h all over a
Times A plus H.
all over h. And you could think of it in terms like this. This is h over 1, right? So really we're dividing a fraction by a fraction. So think of it like this. I've got negative h over a times a plus h divided by this fraction. But when you divide by a fraction, you what? Multiply by the reciprocal, like this, right? And then you'll notice that we can cross cancel, but it doesn't go away. What's h divided by h? 1 over 1. So what we're going to do now is we're going to take the limit of,
If it's a negative one?
it's a negative 1, yep.
Oh, okay.
So we take the limit of this function as h approaches 0, but we're going to end up with negative 1 times 1 is negative 1 on the top. And then that will be over a times the quantity a plus h. We can find out what that is by plugging in the 0 for h, and I've got a times a plus 0, or negative 1 over a times a, which is just a squared.
Why do you put 0 and 3? Oh, because it says it approaches 0. Ta-da!
Now what I've done is I've created an equation where I could plug in any value for a and it will give me the slope of the tangent line. Did you guys figure that out yet? So now the second portion, so what does this mean? That means, let's recap a little bit because we wrote a lot of stuff down. That means that if I'm talking about x or y equals 1 over x, that the average rate of change will always equal negative 1 over a squared, where we set x equal to a. So if I want to know the slope of 1 over x,
Negative 1 over x squared.
I only have to plug it into negative 1 over x squared. So what I've done is I've written an equation that I could pick out any number. Want to know the slope of 1 over x when x equals 3? Plug in 3 for a. Want to know what it is for negative 4? Plug in negative 4. And that'll give you the slope every time. Now, the second part of this question, that was just the first part. What they wanted to know is when was the rate of change equal to negative 1 over 4?
2. X equals 2.
Very good.
Ta-da!
It occurs, so basically, let's solve that though. So how would I find that? I would say negative 1 over a squared has to equal negative 1 over 4, or we could say a squared equals 4, or a equals plus or minus 2. Right, because you take the square root of both sides. Does that make sense?
Yeah, part B is easy.
You're welcome.
Thank you. Wait, how many examples are there?
Oh, man.